Yes, let's start. So, dear students, first of all, I want to know that's from which country do you belong right now? Hamna, first tell me about yourself.
I'm from Saudi Arabia.
Okay, you are from Saudi Arabia. Okay, and Manthavir Bhaskar, you're from?
So I'm from Hyderabad, India.
Okay, and Sara Shakil, you're from?
I'm from Qatar, sir.
And you are from Qatar. Very good, very good. My name is Awais Parvez, and I have been teaching here for last approximately 6 to 7 years. And there are so many students who have topped, okay, in their board examinations. And not only in their board examinations, we have made them so tremendous that they have not only scored very good marks in the 9th and 10th standard, but they have scored many competitive exams. Okay, so without wasting time, first of all, let's start studying. Then after that, we will be going to discuss. Okay, Hamna, Veer, and Shakil. What's the name? Sara Shakil. Okay, so let's start, dear student. So first of all, we are just going to study a very important chapter, that is motion. Actually, the first question arises here, that why there is a need to study motion? Why we are studying? Why we need to study this motion, velocity, another chapter, another topic related to this chapter? Actually, dear students, we need to study this chapter for not only for a single reasons. There are so many reasons. Okay, just for example, just imagine if there is a car. Okay, if there is a building, let's imagine. Okay, if there is a building A, okay, A, and that is approximately 10-meter tall, and you are going to jump another building that is approximately 5-meter tall. Okay, and there is a distance between these two building is 5 meter. Okay, then at what speed you should jump from this point so that you can reach to this point, okay, to that point of the other building. So first of all, we need to calculate this one, but actually our mind is so brilliant that we can assume without, we are not going to calculate. We don't need a copy and a pen. We can assume, and our mind is so brilliant that our mind can calculate such type of calculations easily, and we can jump easily. If we are able to jump, then we can jump. Okay, if our mind says that we can jump from A to B, if it gives us satisfactions that we can jump from from building A to B, then we can jump. Okay, similarly, if you are driving a car, you cannot drive a car, actually you are kids. Actually, if you are driving a cycle, another, okay, and if you are going to overtake another, okay, if you also just imagine that if you are one-way road, okay, you are going to have in a one-way road and you are cycling, okay, and if a car is coming from another side, okay, from your side, so at what speed, and if you have to reach this point A, if you need to save your point, okay, so at what speed should you cycle so that you can reach to that point before this car reaches to you? Okay, this car is moving to this directions. So there the such type of calculations are very easy, and you can easily, your mind can calculate. But what to the robots, what to the aircrafts, automatic aircraft, what to the actually we can say about the rockets and other missiles that's work without human brain? Here we need exact calculations. At what speed should your rocket should fly? At what angle should your rocket should fly? That if you are going to strike your rocket to this position, okay, so that it can reach exactly this position. Okay, if a person, if there is another army, if we are saying there's a war between the two countries or two borders, okay, and A and B, okay, let's suppose, okay, and dear student, if here, let's say there is a rocket and another one is this one, they are fighting, so at what speed that your rocket should fly so that before reaching to this one they can strike on the ground? So This type of calculations are very, very important regarding to the motion chapters. Okay, so sometimes our brain is so much accurate and exact, we can say that it can calculate tremendous calculations are done by our brain, and we can say that our brain can calculate a large amount of calculations that we used to do, okay, daily. We can exert a force, how much force we should exert so that it will break, okay. How much force, at what speed we should we run so that we can reach that point. We can, how, at what speed should we run so that we can catch our train. So this is we don't need the copy and pen during that time, but actually, but when a machine is working, we need the exact calculations. Okay, so for that, dear students, uh, we need an exact calculations, and we need to study this chapter very importantly. And this chapter is actually the base, we can say that it is the base uh, for studying motions in very much great detail. Because if this chapter is not properly studied, or we can say that if we have doubts in this regarding to this chapter, yeah, you have doubt.
Yes, so can you define motion, sir, for me?
Yeah, we are coming to that point. Okay, we are coming to that point. Okay, so what is actually the motion is? Okay, so dear student, motion is simply when an object changes its position. Okay, when an object changes its position from point A to point B. Okay, if this is a point A, or we can say that if this is a car, and if it in motion, and if it is changing its speed, yeah, we can say that if it's changing its position. Okay, the car is here for some time. Let's imagine that this car is here. Okay, this car is, imagine this car is, it's this position, and this pole is a pole. Okay, and this is fixed pole. Okay, and after some time, this car reaches to this position, this car reaches to some other position. Okay, let me take the example. Okay, wait a minute. Okay, let this car after some time reaches to this position. Okay, from A to point B. Then we will say that this car is in motion. Okay, so if an object changes its position, with respect to a reference point, or with respect to a stationary point, okay, then the object is said to be in motion. What I'm saying, I'm repeating my statement again. A body is said to be in motion. A body is said to be in motion, if it changes its position with respect to a reference point in time t. Okay, because every motion needs time. There is no motion, if a body is in motion, it will means if a body is moving from A position to B position, it must take some time. Okay, time is an important dimension for the motion. Okay, so simply if an object is moving from position A to position B with respect to a reference point, we can consider it as motion. Okay, just for example, let's take another example. Okay, dear students, just for example, if you are sitting in a room, okay, so you might not be in motions. If you are sitting in a room, you can assume that you are not in motion. You are sitting, you are not moving, you are on your bed, and you are not moving. Then at that condition, dear student, we can consider that you are in motion. But you are actually in motion with respect to different reference to the different reference point. Okay, for example, just imagine this is our earth. Okay, here is earth. Okay, it is earth. Okay, and this earth is moving with respect to another, we can say that another planets, or with respect to a reference point that we can assume sun. If we are assuming sun as a reference point, with this sun is fixed, this is sun. Okay, and the earth is moving around the sun. So actually, if the earth is moving, we are actually moving. So with respect to a reference point, we are assuming, if we are assuming sun as a reference point, we are in motion. We will consider ourselves as in motion. okay, with respect to the reference point, if you are assuming the sun. But if we are sitting on a bed, and with respect to a reference point, if we are assuming our door or our side window, another, we are not changing our position. Actually, if we are in a room, okay, and this is our bed, okay, this is our bed and this is our window, and I'm sitting here, just suppose if I'm sitting here, so with respect to this window, I'm not changing my position, but with respect to the sun, I'm changing my position. Similarly, we can take another examples also. Okay, dear student, let's assume, let me take another examples. You can assume another example of a moving train. If you are in a train, okay, and if a person, if this is a train, okay, and these are the coaches, let's suppose this is a train, okay, and if a person is sitting here, okay, another person is also sitting here, okay, so if these are the two persons and they are sitting here and they are sitting here, so they are not in a motion. We will consider that they are not in motion. Actually, with respect to each of them, they are not in motion. But if a person is assuming, if a person is standing here, okay, and with respect to this, if the train is moving, actually the person are also moving, so we will consider that these are in motions. So it is about the reference point. So in the definitions, we are considering that if a body is said to be in motion, if it changes its position with respect to a reference point, we need to refer, we need a reference point. We need to, if there is no reference point, we cannot say a body is moving. It might be in motion, it might not be in motion. For example, I'm just explaining you again that if a person is in a train, these two persons are not in motion. Actually, if the train is moving, still they are not in motion with respect to each other. Okay, but if a person is outside and he is watching to these persons, then these persons are in motion. Actually, they are in motion. So it depends on the reference point. What reference point are you considering? Okay, do you understand, dear student, what actually the motion is? You understood, beta? You understood?
Yes.
Sara, Mantha, Hamna, Veer, do you understood, beta? Do you have any doubt regarding to this topic? That what is the reference point?
Yes, sir.
No, sir.
You don't understood.
We understood the concept.
Is there any student, beta, if you have any doubt, if you are not understanding, if you have any language problem, if you have any doubt, please let me know. It is mandatory for me that if may I know that if I'm teaching fast, should I teach slowly? Are you considering me? Is my voice is audible to you? If you are getting any problem, let me know. Okay, beta. So again, I'm going to explain you that motion, what is motion? Simple, the movement of a body. Motion, we can consider it as a simple movement of a body from point A to point B, and it can be from one, don't say point A to point B, you can write from one position to another position with respect to a reference point. It is mandatory that you need to write here with respect to a reference point, because if there is no reference point, we cannot consider that. For example, if in the similar car, if this is a driver, okay, and if a person is sitting on the back of this car, so both of them are not in motion. The car is in motion, but the driver and the others, but the driver and the person who is sitting in the back, they are not in motion with respect to each other. But with respect to this pole, with respect to this reference point, they are in motion. Okay, so I hope you understood, beta. If you have any doubt, then let me know. Okay, let's move to another topic. Okay, next topic is, there are so many types of motion that we have in our day-to-day life. We have broadly divided the motion into 4 parts. Okay, 4 types. Depending on the particle movement or the object, how does the object is moving. Okay, we have divided the motions into 4 types. The one is the rectilinear motion. Okay, what is rectilinear motion? If an object is moving in a straight line does not means this straight line, actually straight line. It means simply like this means if an object is moving like this, then we will be considering it as a rectilinear motion. Okay, if a person is moving, we will consider that it is in rectilinear motion. Okay, means 1D motion. 1D matlab one dimensional motion. Rectilinear motion is one dimensional motion. One dimensional means you can say that the car moving on the road is going to have a rectilinear motion. Okay, if you are moving on the road, it is a rectilinear motion. Okay, sorry, 2D motion. Sorry, 2D. Rectilinear motion is 2D motion. Okay, next one is circular motion. Circular motion, you are very much familiar. What is circular motion? If this is a center and this is a path, okay, and this is a path, okay. So if an object is moving on this, like round like this, so this is considering, we will consider this as circular motion. Like this point, or okay, we can assume by changing the color here. Okay, so this point, dear student, okay, this point, this tip of the clock is in circular motion, because it is moving like this step. Okay, this point is also in circular motion because it is repeating the same. So means circular motion is simple. If an object is rotating, sorry, is moving around a fixed point, we can take this as a fixed point. So if an object is moving around a fixed point, then we will consider it as a circular motion. Another motion is rotational motion. Rotational motion means rotating about an axis, means like the earth also rotate and circulate. Okay, so we can say that like if the fan, you can take an example of fan. The fan, if there is a fan, okay, and we can consider it as a fan. Okay, so if this is a fan, okay, so if the fan is moving, so it is rotating about its axis. This is, we will consider this an axis. Okay, so this is rotating, but the tip of this fan is in circular motion, because the particle present here, the particles of the object present in this blade at this point are in circular motion. Okay, but the fan is actually in rotational motion. Rotational motion is simply if you are rotating something, if you pick up a ball and you start rotating it, okay, it is not moving like this, it is rotating about its axis like this. Okay, like this. So if an object is rotating about its axis, it is considered to be as a rotational motions. And another one is a periodic motion. Periodic motion is simple. If an object's positions repeats after a regular interval of time. Okay, for example, this pendulum. Okay, so if this is A, B, and this is 0 position. Okay, so if an object move from this point, move to this point, and then again then this point, then this will consider as a periodic motion, because repetition of something, repetitions of the movement after a regular interval of time, this is considered to be as a periodic motion. Okay, we'll consider this like this pendulum. It should not go out of the clock, so I should make it inside the clock. Okay, so this pendulum is repeating its motion, its path after a regular interval of time, after a fixed time. Okay, so this will be considered as a periodic motion. Okay, so do you have any doubt regarding to this rectilinear motion? Do you understood? Rectilinear motion is 2D motion, two-dimensional motion. Like if you are walking on the road, if the car is moving, if the train is moving, so we will consider this as a rectilinear motion. If the ship is moving on the water, okay, on the sea, if any motion that you see on the ground, that will be considered as a rectilinear motion generally. And circular motion, you are very much familiar. The circular motion is if an object is circulation. So I think you may have doubt between this rotational and the circular motions. You understood what is rotational? The earth rotate and also circulate. That's example. This is sun. Okay, this is sun. The earth actually is moving around the sun due to, and it takes 365 days, okay, to complete one complete rotation, sorry, one complete circulation. Okay, you understood, dear student? So the earth rotate and revolute apne axis par, it rotate on its axis, okay, and it revolve around the sun. So revolution and rotations both are the type of motions. You can say the circulation is also revolutionary motion also, revolutionary motion. Okay, so if the earth is rotating, due to rotation of earth, we have day and nights, because like you can assume that, let me go back. Okay, this is very small, let me make it properly. Actually this is sun. Okay, and if the light of the sun is reaching the earth and this face, okay, that this is the face and I'm making it axis. So if this is right now, this is USA. Okay, so if this is USA, so India will be here. Okay, India will be here. So dear student, this side facing the sun is going to have day, and after 12 hours, this position will reaches to this one and the USA will come to this side, and we are going to have the India will going to have day and the USA is going to have night. So due to rotation, we have day and night. Okay, and due to revolution, we have seasons. The earth also revolve around the sun. The earth rotate and revolve both. Okay, so do you understood, dear student? So the type of motion, do you understood, beta? Do you understood?
Yes, sir.
Do you have any doubt?
No, sir.
Okay, okay, so let's move further. So the next topic is that's actually when we are talking about the motions, so we must understand about the distance and displacement. Okay, distance and displacement. Actually, why we are studying distance and displacement? Actually, distance and displacements are very important. Okay, distance gives us actual path traveled. It gives the actual path traveled. Okay, and this one is shortest path between the 2 points, or the initial and the final position. Okay, shortest path between we will write the proper definitions. Let me explain you first. Okay, so this is the shortest path between initial and final positions. Okay, final position. So dear student, let's start. Actually, distance is the actual path length covered. For example, if this is a cycle, the cyclist is a boy, okay, and he starts traveling from position A to position B, and then he went from position B to position C. Okay, so actually he ride 4 meter. The distance between this one is 4 meter, and the distance from this one is, let's suppose it is 3 meter. Okay, so actual distance he covered is 4 plus 3 is 7. Okay, 4 plus 3 is 7. But this is the actual, what is this? This is the actual distance, okay. But if we calculate what is his displacement, the word itself indicate, it is initially, yeah, we can say that it is itself showing its meaning, that's displacement. It is the distance between the two positions, shortest distance between the two positions. Okay, so what is it actual displacement? The displacement is initial, the distance between the initial and the final position, shortest path between the initial and the final position. So if the person start traveling from position A to position B, and then he reaches to the position C, and now actually what is the displacement? Displacement is the distance from A to C. And if we calculate this one by Pythagoras, by using Pythagoras theorem, okay, and other mathematical calculations, so it will be 5 meter. Okay, it will be 5 meter. So dear student, here we need to understood there one thing, that the distance is the actual path covered by an object. For example, again I'm going to, if an object is moving from A position to B, let's say it is 30 meter, and then return back to A position. Okay, so what is his distance? he traveled, it is actually 30 plus 30, it will be 60 meter. But what is its displacement? What is his displacements? So his displacement will be 0 because his initial and the final position is same. So the distance between the initial and the final position is 0. He start traveling from A position and come back to his position. So distance, the initial and the final position is same, then we will consider it as that the displacement between them is 0. Okay, so do you understood, beta? Do you understood what is the distance and what is displacement? Do anyone have any doubt regarding to this topic? Do anyone have doubt? No one is going to reply. Actually, the student thinks that no, I'm not going to. I have to open my mic again. So let me ask my name by using the names. Okay. So Hamna, beta. Hamna, do you understood, beta? You understood?
Yes, sir.
Actually, Hamna, in India, if I say beta means loving kids. Okay. So it's my when I used to teach the Indian students. So I usually speak beta. Do you understood? Beta, do you? So beta means in India, in Hindi, we can say that it means loving kids. Okay, so Hamna, you understood? Okay, now we do you understood, beta?
Yes, sir.
Okay, and Sarah.
So do we have some other classes, sir, in which you teach?
Means pardon, do you what you want to ask?
So you should be the tutor, but some other time, or so students of India, not global students.
Okay, you don't you are not comfortable with other students. Why? Do you understand? You don't understand English?
So I do, so I understand English.
Okay, okay. So they are all the other students.
So the international standard and the Indian standard, we have some difference between the portions.
No. Actually, they are both studying in the Indian schools. They are both going to have the CBSE syllabus.
Yes,
You
sir.
don't.
Yes, sir.
Don't
Got it. Got it. Sorry.
don't think so that I'm going to teach you some other. They both are studying in Indian schools in the different countries. India is a very big country, and those students, they are also Indians. Okay, they might their parents might be Indians, or if they are not good relatively, but they are studying their syllabus is same. Okay, that's why they are
Okay.
studying from India. That
So
don't worry about it. We are here just to take care of you. Okay, don't worry about it. Okay.
yes, sir.
So let's move further. So do you have any doubt regarding to this topic that I have to taught you? This one is displacement and distance. I'm going to write the definitions of these two topics. Okay. So do you have any doubt regarding to this? Let's take another examples. Let's take another examples. So if a person start traveling from this position, from A position, and then reaches to the B position, then after B, that he reaches to the C position, and then from C he reaches to D position. Okay, and then again come back to A position. So what is this? If I'm asking, what is his net distance covered? Let me tell. Let me know, beta. If a person start traveling from point A and then he reaches to point B, then from point B he reaches to point C, and then from point C he reaches to point D, and then from point D he come again to his main position, his initial position, that is point A. So what is his actual distance covered?
16 meter.
16 meter. Very good. It will be 16. How? You know, the simply is we have to add 3 plus 5 plus 3 plus 5, and that will be equivalent to 8 plus 8. You can write it 16 meter. Okay, very good. And what is his net displacement?
0 meter.
Yeah, very good. It is 0 meter. Okay, so it will be 0 meter. So this is simple. Okay, so now you know understood. Let me take one more examples. If a person is traveling in a circular path, okay, and his radius is 7 meter, okay, and he start traveling from point A, and then reaches to point B. Okay, means he traveled from point A to point B in a circular path like this. So what is his actual displacement? Do anyone know? What is his actual displacement? If a person start traveling from this position, from point A, and along this path, okay, along this path, and reaches to point B, what is his net displacement? It is simple, beta. It is simple that you need to actually, displacement is the shortest distance between the initial and the final position. So if we start traveling at A from position A and then reaches to point B, the shortest distance between A and B is the diameter of the circle, and that is 7 meter plus 7 meter. Okay, because the radius is a
14
half.
meter.
Yeah, this will be 14 meter. And if I ask, you have studied in mathematics the circumference of the circle. You have studied this formula pi r square. Have you studied this formula in the 8th standard?
Sir.
Yes or no?
Yes, sir.
Yes, you have studied. I know that you have studied.
Sir.
Okay, so if I ask you, what is the net distance covered? Distance covered, actually, the distance is very simple. You have to calculate this, the length of the half circle. You can say that the half circumference of the circle. So sorry, this formula is area. This belongs to area. The half, sorry, 2 pi r. 2 pi r is the formula for this circumference of the circle. Circumference of this circle. Okay. So half this circumference of the circle will be, you can divide it by 2. You will get pi r, and that will be 22 by 7 into 7. Radius is 7. You will get, it will be 22 meter. Okay, so just think, if a circle is of 7 meter and a person is moving along its circumference, then he has to cover 22 meter distance, okay, to reach the point B. But if he is traveling with a jet or something along this, the shortest distance will be, dear student, that will be how much? It will be 14 meter. So I hope you understood the topic, that is distance and displacement. Okay, do you have any doubt regarding to this topic?
No, sir.
Okay, everyone understood?
Yes, sir.
Okay, so there are simple questions just arises from this, but actually we need to study, because this one is, so let's write the definition first, and then we will move to the next topic. Okay, so what is the distance and displacement? Distance, so we can write it here. It is the actual path length covered by an object. Okay, the SI unit of distance is SI unit. You understood? SI unit of distance is meter. Okay, and denoted by small m. We denote it by small m. Okay, meter is a standard unit. Okay, SI unit, we can a standard international unit for measuring the distance. We usually measure the distance in centimeter also, mm also, kilometer also, but the standard unit is meter. Why we are writing the standard unit? Because if you have to calculate any distance, okay, if you are going to calculate any distance, if you are just going to calculate, if you are solving a numerical, and if the distance is given in centimeter, you have to convert it into meter. Okay, if the distance is given in kilometer, then you have to convert it into meter. So meter is the standard unit. While calculating any numerical problem, while we are solving any numerical problem, during that time you need to keep in mind that if the distance is given in another units, in some other units, okay, then you have to convert it into meters. Okay, and similarly displacement it is the shortest path between two initial and final positions Okay, and similarly the SI unit, what should be the SI unit of displacement? Do anyone have any idea? What should be the standard international unit for the displacement? It is simple, but actually we are calculating the distance, na? We cannot, let's give an example again. Okay, let's take, if a person is moving from point A and then he reaches to point B, and then from point B he reaches to point C. So actually we are just, if we calculate the distance, that will be 7 meters, 4 plus 3. Okay, and if you are going to calculate the displacement, that would be 5 meters. Actually this is also a distance, but it is the shortest distance. So we cannot say no, it is displacement, we have to measure this in liter, we have to measure this in you can say that you can use another unit, like we have to use in decibels. No, it is actually a distance, but the shortest distance between the initial and the final position. So the unit should be same, that is meter. So both the displacement and distance are going to have the same unit, and that is meter. Okay, so both of them are going to have the same unit. So I hope you understood, dear student. So if you have any doubt regarding to this topic, you can ask. Do you have any doubt, beta? Do you have any doubt?
No, sir.
Hamna, Veer, Sara? No. Okay, doesn't matter. Let's start. Okay, let's move further. So now you are very much familiar, and you might solve problem. You might be able to solve the problem between regarding to distance and displacement. Okay, so another topic is regarding to this chapter is the types of motions. We have studied types of motion regarding the how the particles is behaving. Okay, if the particle is that we have divided the motion here, we have described the motions in rectilinear motion, circular motion, rotational motion, okay, periodic motions. So actually, dear student, this category, yeah, we have divided this 4 types of motions on the basis how the particle is behaving, how the particle on an object is behaving. Okay, what kind of motion is it? Now we are dividing the motions into 2 parts. Okay, one is the uniform motion, another one is the non-uniform motions. Okay, so motions again we are dividing into 2 parts. One is the uniform motion, and another one is the non-uniform motion. Okay, and actually the chapter start from this topic. This is very, very much important, and because the graphical representations regarding to this topic is very important, and the questions generally asked, the students are going to have the doubts. So please, it's my request that study this topic very clearly. If you have any doubt, ask again. Okay, so what is actually the uniform motion? Uniform, the word uniform means constant. Okay, something constant is described as uniform motion. So what is uniform motion? If an object is traveling with a uniform speed, okay, if an object is traveling with a uniform speed, means a fixed speed, okay, then it will consider that object that it is moving in a uniform motion. Okay, so uniform motion means traveling equal distance in equal time of interval. What do you equal distance in equal time of interval? Okay, Equal distance in, what does this means? Equal distance in equal time of interval. Let's describe the elaborate this topic also. Okay, so let's assume, dear students, if an object is moving 5 meter in 1 second, okay, and in another 1 second, it again travel 5 meter, another 1 second, it again travel 5 meter. Okay, so this type of motion, if an object is traveling equal distance in equal time of interval, we will consider this as uniform motion. Okay, but just suppose if an object is moving in 1 second, it's traveling in 5 meter. Okay, then again next 1 second, again travel 5 meter, but in another 2 seconds it travel 5 meter. So at this point, okay, from here to here it is in uniform motion, but from here it is in non-uniform motion. Why? Yeah, overall we can say that this object is moving with non-uniform speed, or we can say that it is not covering equal distance in equal time of interval. Means here in 2 seconds this object must cover 10 meter distance, but instead of 10 meter it only covers 5 meter distance. So dear student, here we can say, we can consider this, that the object, we will consider this object as in non-uniform motion. Non-uniform motion. Okay, but you understood? You understood what is what does the statement means, equal distance in equal time of interval?
Yes, sir.
You need not to write the lengthy definition. You need not to memorize lengthy definition. Just learn or memorize the keywords. Equal distance, equal time of interval is the definition for the uniform motion, and non-equal distance, or we can say that unequal distance in equal time of interval. Okay, so unequal distance in equal time of interval, this is a simple definition for the non-uniform motion. Let's take the examples. So do you think, yeah, let me ask one simple questions. Give me an example that you see in your daily life that is moving in with a uniform speed, or uniform, that is performing the uniform motion. Just think around in your room, in your daily life, if you are moving somewhere,
Ceiling fan moves in a uniform motion, sir. Uniform motion and uniform speed also.
Okay, yeah, uniform motions. Okay, yeah, you can say that. But initially, and when we turn off the fan, during that times it is not in, it is, we can say that it is in non-uniform motion. But after certain time, when its speed reaches to a fixed rotational speed, then during that time we can consider this is in uniform motion. Okay, another example, dear student, do anyone have any idea? Just think and just give an example. Clock.
Yes, sir, clock.
Clock travel. Yeah.
So, and when certain factories, when things are made, so the things go from place A to place B in a particular speed.
Yeah. Very good. You have seen this in many movies, and many the persons are moving. They are just someone are packing their objects, so they are moving in a particular speed. Okay. Yeah, you are right. Okay.
Yes, sir.
Okay. In the similar way, at airport. Okay. Or you can say on the railway stations, you have seen the you can say that what accelerator. Okay, so the accelerators is moving with a uniform speed. Okay, we right, generally accelerators are moving, or we can say that the belts, the conveyor belts on which our traveling bags comes. Okay, when we reaches to the airport. Okay, so during that times also our bag is coming on this conveyor belts. Okay, so this conveyor belt also moves with a uniform speed. Okay, so this is also a uniform, we will consider that it as a uniform motion. And non-uniform motions are, you can give thousands of example of non-uniform motion. Okay, moving a car generally moves with the non-uniform speed, because if someone comes in front of you, you need to brake. If someone,
Yes, sir. So
okay,
even when humans run, so
even
at starting we have a great speed, but in middle
yeah,
or at the end we reduce our speed.
yeah, very good, okay, very good. So Hamna and Sarah, do you have any doubt, beta? Do you understood the topic, the
Yes, sir.
uniform motion and non-uniform motion? It is simple. If an object is traveling, you need not to write. If an object is traveling, no need to write the whole definition. It's right, simple. Objects, if object cover equal distance, equal time of interval, we'll consider it as uniform motion. Okay, this is simple uniform motion. So if an object is covering equal distance in equal time of interval, it is uniform motion. And if an object is covering unequal distance in equal time of interval, unequal and equal, you need to write here equal. Don't write unequal and equal on the both side. Okay, so equal distance in, sorry, unequal distance in equal time of interval, we will consider it as uniform motion. Okay, now let's talk about the graphs. Let's take an example for the uniform and non-uniform motions. Okay, let's study the graph. Are you familiar with the graph in the 8th standard? Okay.
Yes, sir. So
Yeah. Okay. So this is velocity time graph. Okay, let's take an example. First, we will going to take an example of velocity time graph. Yeah, speed time graph. Speed time graph. Okay, so let's take example. This is the speed is 30. Now here the speed is 40 meter per second. Here the speed is 50 meter per second. Here the speed is 70 meter per second. Sorry, 60 meter per second. 60 meter per second. Here it is 70 meter per second. Okay, it is in first second. The time is 2 second, 3 second, 4 second. Okay, so I'm going to make another same graph here.
we are
Okay.
basically studying types of motion, sir. Uniform motion, non-uniform motion.
Yeah. Here we are also drawing the graph of uniform and non-uniform motion. Okay.
Okay, sir. So and after this we'll go to Newton's laws of motions, no, sir?
Yeah. Newton laws of motions we will going to
Yes, sir.
study,
Three laws.
and
Yes,
yeah, in this chapter. But actually, first of all, we have to study different other remaining topics also. Before we come to that topic, we have to study the scalar quantities, vector quantities, average velocity. Okay.
Okay, sir.
So we are going to study that topic also. In this class we may study that one, but I think in the next class it will be more suitable to start with the fresh topic. Okay, so this is 60 and this is one is 70. Okay, so I'm drawing this one. I'm going to just draw this one, and just think and use your brain. Don't stress, just think, simply think, which one is the uniform motion, which graph is representing the uniform motion. This
So
is
the
graph,
first graph.
this is the graph A, and this one is the graph B.
So the graph A.
Graph A. Okay. Hamna and Sarah. Hamna and Sarah.
Yes, sir.
Beta, I want to ask, do you understood
Yes, sir.
why Veer is saying that graph A is indicating the uniform motion?
Yes, sir. Because it is having equal distance and equal interval of time.
Actually, this is the speed.
Yes.
This one is the speed, and we are saying that speed time graph. So here this car is moving. The car is going to have 50 speed. Okay, in the first second it is 50, and another second it is also 50, another second it is also 50, another second it is also 50. So if the speed is constant, if you are driving a car, okay, just imagine you are driving a car, okay, and you set your speed 100 km/h. So if you are traveling, if you fix your speed, it is 100 km/h, then during that time you will be covering equal distance in equal time of interval, because the speed is constant. What is that is making unequal distance covered in equal time of interval? That is the non-uniform speed. If the object is not traveling with a non-uniform speed, yeah, if the object is traveling with non-uniform speed, so during that time we will say that it is in non-uniform motion. But here the speed is fixed, 50 is fixed. Each time you can say that if I ask what is the speed of at 2 seconds, so it is 50. You can write here, this is 50. What is the speed at 3 seconds? It is 50. What is the speed at 4 seconds? It is 50. So since the speed is constant, okay, since the speed is constant, we will consider this as uniform motion. Okay, now just come to graph P. This graph is indicating the non-uniform motion. Non-uniform motion. How this graph is indicating the non-uniform motion? Let's me explain you. Okay, let me make this one. Okay. So if I ask you that, I'm asking to Sarah. Okay, Sarah, beta, tell me what is the speed of the car on 2 seconds?
Yes, sir.
What is the speed of the car at 2 seconds?
40.
40. Okay, and another student, that is Hamna. Hamna, tell me what is the speed of the car at 4 seconds?
60.
It is 60. So is the car is moving with a uniform speed? You think the car is moving with a uniform speed? Here the speed is at 2 seconds. The speed is
Sir, no, sir. It changes its speed, sir. At
yeah.
30, 40, 50, 60.
Every second speed is increasing. At every
Yes,
second, it is 30. Another 1 second it takes 40.
so
Then
there's
another
there's no constant speed.
Since the speed is not constant, so we will consider it as non-uniform motion. Let me take another graph. Okay, it is a distance time graph. Okay, let me use another slide here. Okay. Okay, so now I'm previously I make the speed time graph. Okay, this is one is the speed time graph. Let me make here the distance time graph. Distance and versus time graph. Okay, another. This is distance versus time graph. Okay, now I'm just going to right here. This is 10 meter, and this is 20 meter. This is 30 meter. This is 40 meter, and this is 50 meter. Okay, now here it is 1 second. It is 2 seconds.
So your presentation stopped, sir, for me.
Is it not working? It is not visible to you? Okay, let me check again.
Yes, sir. Sir, if you ask others.
So, beta, is my screen is visible to you? Sarah and other student?
Yes, sir.
Is my screen is visible to you, beta? Is it visible to you now?
No, sir, it's not visible.
Let me do it once again. Let me stop share. Okay, let me share it again. Is it visible to you now?
Yes, sir, now it's visible.
Okay. Okay.
Thank you, sir.
Okay, beta. So this one is distance, again, distance time graph. Okay, so this is 10 meter. Okay, 10 meter. Then another is 2 seconds. This is 3 seconds. This is 4 seconds. This one is 5 seconds. And again, I'm going to writing here 10 meter, 20 meter, 30 meter, 40 meter, 50 meter. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so this one is distance, this one is time graph. Okay, I'm going to make this one a graph here like this, and this one the graph here like this. Okay, like this. Just use your mind and just think that which graph is showing the uniform motion, graph A or graph B. Just use your mind, just think, don't be suppressed, just think easily what information are you getting from the graph A and what information are you getting from the graph B. You can take as much time as you want, but just think.
Could you repeat the question once? I got disconnected.
Okay. I'm asking here, dear student, that we have the two graphs on the screen right now. Okay. And let me know which graph is indicating the uniform motion. Graph
So
A.
the second graph is representing uniform motion, sir, because
Here.
the speed is, yes, sir, because the speed is constant at 30, and in the first graph it changes, sir.
Actually, beta, we just look at again. Look at it is not the speed time graph. It is a distance time graph.
Oh, sorry, sir.
Just tell me now. Just use your mind again. Just stress your mind. I know you are a brave student. You can give me the answer. You can, and that is very simple.
Sir,
Try it.
So it is B, sir.
B is representing the uniform motion. According to Veer according, this one is uniform motion. Okay, Sarah and what is the name actually? Sarah and Hamna. Okay, Sarah and Hamna, try.
Yes.
Did you try, beta? What informations are you getting from graph A and graph B? Just use your mind, relax. Don't think what the other student will think. No. You are not going to think that's the stupidity. Okay, we are not going to think like that. We don't get any kind of, don't think. Actually, those students who are not going to stress their mind during the time of study, they actually score. Actually, the study become boring to them. We are not going to study for the board exam. We are not studying here just for the board exam. We are just studying in how the studies is going to make interestingly. We are just making our studies interesting. Okay, so let me know. Just think, use your mind. What the informations are you getting from graph A?
I guess it's the graph A that shows uniform motion because the difference of each one is 10 and it's a uniform speed, while the second one it's constant and your distance should change, so it's not moving, it's at rest. It shows that within 5 minutes it did not move from its place, so I guess it's at rest. Rather, the graph A is at uniform motion because the difference is equal while the time moves on.
Yeah.
With respect to time.
Okay. So Hamna, do you think Sarah is correct?
Yes, sir.
Oh wow, very good. So actually we here we need to correct you that what informations are you getting from graph B? Actually in graph B, you see the distance at the first second. The distance covered by the object at the first second is 30 meter. At 2 seconds, it is 30 meter. At 3 seconds, it is again 30 meter. At 4 seconds, it is 30 meter. At 5 seconds, it is 30 meter. Okay. So since the distance at every second, the time is increasing, but the distance is constant. What do you think? If you see a car, okay, in your parking, if you see that car at 1 p.m., it is standing in the garage. At 2 p.m., it is still in the garage. At 3 p.m., it is still in the garage. So do you consider the object is moving? Veer, do you consider?
No, sir. I was
No,
wrong.
sir. No, beta. Don't say that you are wrong. Just a simple misconceptions. You can say that you are here just to learn. Okay, so we are just here to just to teach you. Just simple. Okay, you gave an excellent answer in the previous questions. Okay, so I'm proud of you. I'm proud of all of you. Okay, so let's explain it one more time. So in this graph, the object is not moving. Not moving means if the object is not moving, we can say it is not in it. Since it is not moving means no motion. No motion means no uniform. No, not uniform. Okay, so motion, if there is no motion means we will consider it as okay. So here, okay, let's move. Let's understand to the graph B. Yeah, here the Sarah explained. I'm proud of you, Sarah. Sarah, you explained in a very excellent manner. Okay, here the Sarah is explaining that in the first second the car is at 10-meter distance. In the 2 second, the car covers a distance 20 meter. In 3 seconds, the car covered the distance 30 meter. In the 4 second, the car has covered the distance 40 meters. In the 5 second, the car has covered the distance 50 meter. So since in every 1 second the car is covering 10-meter distance, if a car is covering 10-meter distance in every second, so we will consider it as uniform motions. Okay, so just don't get fooled when you get your examinations that if the straight line, if we have the graph, okay, and if it is a straight line, it means it is a uniform motion. No, you have to see that which kind of graph it is. If it is distance time graph and it is a straight line, then it is uniform motion. And okay, and if it is velocity time graph, or you can say the speed time graph, we'll consider speed and velocity laterally. Okay, so if it is speed time graph, okay, then during this time, dear students, that speed time graph, and if you are going to straight line, this means speed is constantly increasing with time. The speed is increasing constantly with time, and if the speed is increasing constantly with time, speed is increasing constantly with time. So that will be the non-uniform motion. Okay, so do you understood this topic? Do you have any doubt regarding to this topic, the graph regarding to uniform and non-uniform motion? Sara, Veer, and Hamna,
No, sir.
everyone understood?
Yes, sir.
Yes, sir.
Okay.
The B graph, it's on rest, no, sir.
Yeah, it is not moving means on rest.
Yes, sir. Okay, sir.
On rest. Okay, and this one is uniform motion. Uniform motion. Okay, so let me give you one other examples also. So
Sir, if you give examples for both.
okay. If you have a graph like this, okay, this is the speed time graph. Okay, speed time graph. Okay, yeah, okay, let me give you, I'm not making such type of curve, let me make it like this. This one is object, this one is distance time graph, okay, and this one is like this. Okay, and another graph is, this one is distance time graph, another one is okay. Just think, just relax, okay, and just think which of the graph is possible, which is the correct graph, means which of them, which, this one is A, this one is B, which graph is possible and which one is impossible graph. Just think, this is 10 meter, this is 20 meter, 30 meter, 40 meter, 50 meter. This such type of questions generally asked in the objective when you are just going to give any competitive exams regarding to this. Okay, this is first second, this is 2 second, this is third, fourth, and fifth. Okay, just think, use your mind, stress your mind, just think what informations are you getting from these two graphs and which one is possible and which one is impossible. Meter, 20, 30, 40, 50, 60. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Yes. Use your mind, take your time.
What should we tell, sir?
You have to tell me that which graph, A or B. In these two graphs, one is A, another one is B. One is impossible graph, which is not possible. Okay. So which one is impossible graph? Okay, I'm going to make one more.
So B, I suppose.
B, you suppose. Don't have any reason, but only tukka. Hana?
Yes,
Don't have
sir.
any. Okay. Okay. 10 meter, 20. This is 10 meter per second. This is 20 meter per second. This is 30 meter per second. This is 40 meter per second. Okay. So this one is 1 second, 2 second, 3 second, 4 second, and this is the time. This is velocity, a speed time graph. This is speed time graph. Okay. Speed time graph. And again, I'm going to make the same graph like this. So Hamna and Sarah, do you want to say something regarding to these two graphs?
Yes, sir. I guess the B graph is impossible because it's the distance graph, distance time graph, and which the time has to move on. So yeah, that's not possible because when it's at 40, it should be at least 5 or anything that is more than 2. I guess because time moves on.
So
Okay.
time can't go back.
Yeah,
Okay.
exactly. So
Yeah,
maybe
Hamna, do you want to say something regarding to this?
B, I guess.
Do you have any reason? No. Okay. But any graph which is going to have the two different position in the same time, do you think that if a car is moving, okay, when a person does a crime, do you think if a person does a crime, okay, and let me explain you what I was saying. Actually, if there is an innocent person, but some other person, your other people are saying that this person has committed the crime, okay, so what does he say? Generally, if he did not did the crime, then he say that no, I was not there at that position. I was not there at that time. I was some other way. Let's check the CCTV camera. You can check that I was there. I was moving the train during that time. I have not done that crime. I have not done that crime because I was not there at that position during that time. So what does it is indicating that if the court proves that the person was not there at the crime position, he was on the other position, so he will be proof, we can say that he will be proof unguilty. Okay, what actually the graph is saying here, that at the same time, if you see that at the time 2 seconds, the car is at the position at 15 meter, then again at 30 meter approx, then 40 meter. Is it possible a single object is going to have 3 different positions in a single time? No, it is not possible that a car cannot have 3 different positions in a single time. So any graph that cuts time axis more than one time, it is an impossible graph. Okay, simply at single time a car can have a single velocity, a single time a car can have single position. You cannot have different positions at a single time. If I'm saying that the car A or car B or whatever the car, if an object is moving, it must have one single position at a single time. In this graph, if you see that the car at 2 seconds, it is in 15 meter approx, at 3 seconds it is approximate 18 or 19 seconds, at 4 it is 30. Okay, so at 5 it is approximately 40. So here a single time there are different position of the car, but here in such type of graphs, the time axis is cutting its multiple times. So if the time axis is cutting, any graph in which the time axis cut, the distance or y-axis, you can say that any for the multiple times that will be considered as impossible graph. Okay, that will be not we will say that this is an impossible graph. In the similar way, if I'm saying that the car is moving with a speed of 20, so at the position 2, or we can say that at position here, the car is going to have different velocity, different speed. This is not possible. A car can have single speed a single time, cannot have different speed in a single time. Okay, so such type of graph is considered as impossible graphs. Okay, do you understood? You remember, keep in mind that if a time axis is cutting multiple times, then we will say that this is an impossible graph. Okay, you understood, beta? You understood? Sara, Hamna and Veer?
Yes, sir.
Okay.
Yes, sir. So in the third graph also, sir, it won't. It's it's impossible, no, sir.
Yeah, in the third, these two
So,
graphs
but
have,
but if you made a S in simple terms, sir. So if the first line doesn't cut the second line, and the second curve is a little bit ahead, sir. So it is possible, no, sir. I hope you getting what I said.
here in the first one, na?
No, sir. Sir, if sir,
Yeah,
I should.
yeah. This is a curve graph, but it is not
No,
cutting.
sir. So, so if it cuts the, so if line cuts once or twice.
Yeah. If it cuts only one time, it is possible. If it cuts twice, just suppose if I make this graph like this, it is again an impossible graph. Okay, at the 5 second, it is cutting 2 times. So this will be considered here till here. It is possible. Okay. So
Okay, sir. Got it.
got
Yes.
it.
Yes, sir.
So let's make a quick revision. Then we're going to quit the class and we're going to take you the feedback. Okay. So
What are the timings, sir, from 8:30 to
8:30 to 9:30. Actually, we have, I was so interested in teaching that I forgot to quit the class at 9:30. Okay. So let me explain you again what is motion. Motion is simply an object changes its position from point A to point B. Okay, with respect to a reference point. Reference point is very important because again, I'm going to explain you. This one is according to the reference point of the drivers, and this one. These two peoples are not in motion, but if we take the reference point as a pole, the object is in motion. Yeah, we can say the person are also in motion. Okay. Another, we give an examples related to the sun. Okay, if a person is sitting in the room, and according to the reference, if we consider window as a reference point, we are not in motion. But if we consider sun as a reference point, we are in motion. Okay, again, the motion we have divided the types of motion into 4 parts. Rectilinear motion means 2D motions, simple, moving in a straight line. If you are moving on the road, car moving, walking. Okay, so this type of motion is considered. We are not considering the plane. Airplane is not considered. Sometimes aeroplanes is moving ahead and also moving upward, so we will not consider it that rectilinear motions. When plane is moving upward also and moving forward also, the upward and forward conditions are different types of motion. So we will not consider plane, the motion of the airplane, as a rectilinear motion. So motion, if it is in a straight line, or we can say in the 2D dimensions, okay, so we will consider it as rectilinear motions. Another one is circular motion. Circular motions you are very much familiar. A rotational motion, rotating about an axis. Okay, and the periodic motion is simple. Periodic motion means if an object repeats its path after a fixed interval of time, we will consider it as periodic motion. Okay, the to and fro motions. And then I have explained you the distance and displacement. Distance is the actual path covered, and displacement is the shortest path between the two positions. So yeah, we can say the initial and the final position. Okay, the next one is, I have given you example and we have solved this one also. This one is the distance is 16 meter and the displacement will be 0 if the person come to his position A. Okay, the next move, we have written here the definitions. Both of them are going to have the same SI unit, that is meter. Okay, we will forward you this PPT after the class is over. So don't worry about it. You will get the notes. Okay.
So
So
how will you forward it, sir, on WhatsApp?
yeah, WhatsApp group. Okay.
Okay.
So this one is we have taught you about the motion and non-uniform motion. What is motion? Uniform motion is simply equal distance, equal time of interval. Non-uniform motion, unequal distance in equal time of interval. Equal time, here it is equal, here it is unequal. Okay. So next one is you are very much familiar. I've given examples regarding to this. The important topic is just to understood the line, the graphical representation is very important. So there's a speed time graph. In a speed time graph, the straight line represent the uniform motion. Okay, straight line parallel to time axis. Straight line parallel to time axis represent the uniform motion. But in distance time graph, the straight line, okay, with a constant slope we will teach, we will study in some other class. Okay, so this one will be considered as, this line is representing the uniform motion and this one is representing the stationary. So you need to understand, you need to keep in mind that what the graph is showing you. Okay, the next one is, we have given you an example that which graph is possible and which one is not possible. So if the time axis is cutting multiple times any object, because a single thing can happen, okay, in a particular time. No two things can happen for a single object. As object can have a single speed, object can have a single distance in a single time. An object can't cover multiple distance in a single time. Okay, so this is not possible. So we will consider that these graphs are impossible graphs. Okay, these are impossible graph. Impossible graph, and this one is possible graph. Okay, so I hope you understood, all of you. Okay, so beta, do you have any doubt regarding to this? And finally I'm going to ask you, you understood?
Sir, I have a doubt. Let's
Yeah,
say if a person covers 3 meters at
yeah,
point A, and then he covers 7 meters at point B, and then he covers 3 meters again at point C. So what's the displacement? I can add on like 13 as the total distance, but what is the displacement?
actually you are saying that this one is 3 meter
3
and
meter,
this one
and
is
that's
7,
7, and
and
then
then
there's next one which is 3.
again 3
So
meter.
what? Yes.
What? So you have to calculate. This one will be the initial and final position. Distance between the initial and final. This one is initial position, and this one is final position. So the distance between these two positions is 7 meters. So displacement will be 7 meter. Displacement
Okay.
will be, okay, displacement
Is 7.
7 meter, and distance actual path covered, that is 13 meter. Okay.
Okay, sir. Thank you.
Okay. So I have understood. Okay, beta. Good night. Take care. Okay. See you in the next.